Welcome back, students. Let's resume our discussion. This is a grand summary of what we discussed in the previous video segment. Sine, cosine, and tangent, the three standard trigonometric ratios, are defined as opposite over hypotenuse, or y over r, adjacent to hypotenuse, x over r, and finally opposite over adjacent, y over x. And they're all, go to this picture here, red right triangle inscribed in this blue sector. How about the other trigonometric ratios, cosecant, secant, and cotangent? They're nothing more than reciprocals. R over y, r over x, x over y respectively. Therefore, they are just reciprocals. One over sine, one over cosine, and one over tangent. Now, let's go to an example problem to solidify our understanding. And here's the first example. Let cosine of alpha is 3/4, and alpha is an acute angle between 0 and pi over 2. Find the other trig values of alpha, which means sine of alpha, tangent of alpha, cosecant, secant, and cotangent of alpha. We have to find all 5 of them because one of them is given. How do we do that? The best way, in my opinion, is to draw a picture. Here we go. Draw a triangle. You don't have to inscribe it in a circle. Just put it in the standard position where your center angle is in the lower left-hand side corner, and the right angle is in the right-hand side, and then the top angle is the complementary angle of your main angle alpha. Now cosine is given as 3/4, so that's adjacent or over hypotenuse. So that's 3, that's 4. From this, it is possible to find out the remaining side using the Pythagorean theorem. 3 squared plus x squared has to be the same as hypotenuse squared. This is what we get. 3 squared plus x squared equals to 4 squared. 4 squared is 16, 3 squared is 9, therefore we have x equals to 16 minus 9, that's 7. By taking square root, you get x equals to square root of 7. Now you can replace this x by square root of 7. Once you do that, you have opposite, square root of 7, adjacent, that's 3, and hypotenuse, that's 4. We get all those. As a result, we get all the trig values that we are interested in. Sine is opposite over hypotenuse, so square root of 7 over 4. Cosine is given. Tangent is opposite over adjacent, square root of 7 over 3. And then how about the other values? Just flip the numerator and denominator. They are all reciprocals. Next, solve the given right triangle, that is, determine A and B from the following picture. Let's see what we have. A and B are known, right triangle, and this hypotenuse is 12. Consequently, this angle should be 60 degrees because these two angles must add up to 90 degrees. Or as a matter of fact, all 3 angles add up to 180 degrees, and this one is 90 degrees, so 30 degrees plus 60 degrees, well, that's 90 degrees. So how do we begin? Let's find out A first. A over 12 adjacent over hypotenuse is cosine of theta. That's the definition of cosine. And from this you can solve for A. Just flip this 12 to the other side. Multiply this. Okay, I finally succeeded. Alright, multiply the highlighted number 12 to the other side, and you get A equals to 12 cosine of theta. 12 cosine of 30 degrees. And use your calculator to figure out cosine of 30 degrees. It'll turn out cosine of 30 degrees is square root of 3 over 2, precisely. We're using Mathematica, so I can easily check. cosine of pi over 6. 30 degrees is pi over 6. Is square root of 3 over 2. And we have precise explanation, precise notation, 6 square root of 3. And then of course, if you want decimal value of it, 0.8866, something like that, and you're gonna get not so precise value but approximate value. I'll accept it at full credit, even though personally I prefer precise explanation. Now how about the other side B? This time let's use sine. This is opposite, so opposite of hypotenuse. B over 12 is sine of 30 degrees. And again, let's flip this 12 to the other side. You get B equals to 12 sine of 30 degrees. What is sine of 30 degrees? Turns out 1/2. So multiply by 1/2 here and you get 6. Now if your angle is a little bit more complicated, not 30 degrees, but something like 26.5 degrees or something, in that case you probably will not get precise expression. So you'll have to use some digit string. Now if you're going to use calculator, make sure your calculator's angle is correctly set up. If you're going to use DMS measure, set it up as DMS measure. If you're going to use radian measure, then set it up as radian measure. So much for the example, and that's where we're going to stop this short video.